His books are used as textbooks all the time. But in my undergrad, instead of using the Griffith quantum mechanics, we used Peebles. So why can't we get 30 likes? Okay, thanks. Yes, of course, Griffith. Just do Griffiths. Why not? David Griffith. He writes good books, good textbooks. So another view is the many worlds interpretation. In this, every time an experiment is performed, for example, every time a photon passes through the slit device, the universe, as it were, splits into two. In one universe, the photon goes through the left-hand slit, and in the other, it goes through the right-hand slit. Oh my gosh. If this happens for every photon, one ends up with an enormous number of parallel universes. All possible outcomes of all possible experiments occur in this ensemble. But before I head off into a parallel universe, let me resume the thread of the story. So parallel universes, too, is something that's sometimes suggested or sometimes thought of. It's very sci-fi-y. And again, I don't know really what to think about parallel universes. I don't know if they are a thing or not. Not my sort of forte. Forget what? So I described the standard model of, so this book describes the standard model of fundamental interaction. So we talked about the standard model of particle physics, for example, including, remember, all the particles, the leptons, the quarks, and the bosons, and also the force carriers. So remember that the bosons were the force carriers. And class, what were the fundamental forces of nature? Everybody? So the fundamental forces of nature are, tell me. Eversore. Hi, Free Energy Mobile. How are you doing? Gravitation is one of them. And next. Electromagnetic force is one of them. Strong nuclear force and weak nuclear force. Come on, guys. We've talked about this so many times. So many times. What are the fundamental forces of nature? Gravitation, electromagnetic force, strong nuclear force, and weak nuclear force. Those are the four fundamental forces. The non-gravitational ones are unified at certain extreme energy regimes. Remember this discussion? Gravitation is not unified with those three. And this is the issue. Okay, we will keep going. The three forces it incorporates are all described by quantum theories. The fourth of the fundamental interactions is gravity. So, quantum mechanics does a good job of incorporating electromagnetism, strong nuclear force, and weak nuclear force. Of course, strong and weak nuclear force, these are being discovered well into quantum mechanics and particle physics being a thing. At this point, of course, the standard model is not going is going to do a good job of explaining these things, right? So electromagnetism, those are carried by the force carrier of photons. Photons carry electromagnetism. Electromagnetism, light, remember? Light's particle nature is photons, so photons carry electromagnetism. Strong nuclear force. What? Everybody, listen